So what we're looking at here is section 4.4. And we've been dealing with trig functions, and now we're talking about trig functions on any angle. Before we were talking about trig functions in terms of right angles, but now we're talking about trig functions of any angle. Can't read my own handwriting. So the definition of trig functions of any angle is as follows. We will let theta, keep in mind that theta is just like x or y. It's just a variable that stands for an angle. It's an angle variable. I could call it beta. I could call it alpha. I could call it anything. Those are the terms we use when we're looking at variables for angles. We use Greek letters. Be an angle in standard position. Be an angle in standard position. What does an angle in standard position mean? It means if I have straight, I can draw this. An angle that's gonna start here, right? And then it can just go anywhere else, right? But standard position means that it's starting on this line right here, right on our x-axis. So let theta be an angle in standard position. All it means is it's any angle that starts on this line and then goes one direction or another. With xy, as a point on the terminal side of theta. On the terminal side of theta. What does that mean? That means up here we have a point, xy, right? This is our terminal side. This is our initial side. This is our terminal side. And r, which is our radius, equals x squared, square root of x squared plus y squared. And it can't be equal to 0. So the first thing we need to look at is we've got an xy and we have an r, right? Normally we don't have an xy and an r. We've been dealing with x and y. And that is fine in terms of right triangles, but we're not dealing with right triangles anymore. So we need to find an r, a radius. And then we can break down our sine, cosine, tangent, etc. So the first thing we need to know is that sine of theta, when we're not dealing with a right angle, is y over r. Cosine of theta of any angle is x over r. Anyone guess what tangent of theta might be? No guesses? Yeah, William, exactly. It's y over x. And as you might be able to guess, well, first of all, we also have to say that x cannot equal 0 on this. Not something we have to worry about when r is in the denominator, because it's a square root. It's going to come out positive no matter what. So we don't have to mention that it's positive, because we're already guaranteed a positive with that, because we're taking it out of a square root. So what else do we have? We have cosecant. Cosecant of theta is just the inverse of sine. So if we have y over r for sine, cosecant is just r over y. And in this case, y can't be equal to 0. Secant of theta is just the inverse of cosine. So it's going to be r over x. And you probably have guessed by now that x cannot be equal to 0, because we can't have 0 as a denominator. Cotangent of theta is just going to be the opposite of tangent, right? The inverse of tangent, which is x over y now. And in this case, y can't be equal to 0. And I've made it so that this section is the only part we're doing today. So I gave you a lot of homework problems, but I really, but only on one topic, and it's this. So let's do, let's do an example. So let's let -3, 4 be a point on the terminal side. Of theta. We want to find, it just asks us for 3, but we're going to find all 6 trig functions, because all your homework ones ask for all 6 trig functions. And it's asking us for a value, right? So the first thing that we want to look at is, what does it mean to have -3, 4 be a point on the terminal side? So you draw a picture. And I can say, all right, I know I have to start here, right? And -3, 4 is going to be somewhere in here, right? I don't even have to think about it. It's going to be at like -1, 1, 2, 3, 1, 2, 3, 4. But it doesn't really matter a ton where it is, as long as we know what quadrant it's in, right? So this is going to be my point, -3, 4. So the first thing we need to do is know what everything is. And we know right now what our x and y are, because it's given to us in a point form. We know that x equals -3. We know that y equals 4. What we don't know is what r equals, right? So before we can begin, we have to determine what our r equals. And the way we do that is we use the formula r equals x squared plus y squared, the square root of x squared plus y squared. And in this case, that just means that we have -3 squared plus 4 squared. -3 squared is just +9, and 4 squared is 16, so we get 9 plus 16. which equals the square root of 25, which equals 5. Now, I know you're taught often when we're talking about square roots that it's really not just 5, it's plus or minus 5, right? We could have the -5 times -5 also equals it. But when we're discussing distances, and that's ultimately what we're using here is the distance formula, we can't have a negative distance in this case. So it's always going to be your positive. Your R will always be a positive. And so now we know what our R is, and the rest is just filling in the blanks, right? We need to know, well, what are our 6 trig functions? Our 6 trig functions are sine of theta, which we know equals y over r, which we can just say is 4 over 5. Then we have cosine of theta, which we know is x over r, which is just going to be -3 over 5. Tangent of theta, we know is y over x, so we're looking at y over x equals 4 over -3. It always helps to remember that cosecant goes with sine, because I always want to put it with cosine. I always want to make it the inverse of cosine because they both start with co, but it is wrong. It is the inverse of sine, which means that we can just flip this over. This is just 5 over 4. When we're looking at cosine, at secant, that is the inverse of cosine. So we would have 5 over -3. And for cotangent of theta, it's just going to be x over y. So it's just -3 over 4. It's not difficult. There's really not a lot of work to show in this part. Where you're showing the work, sorry, I covered part of the answer. Where you're showing the work is how did I get all of the pieces, right? So I need you to show me that you know how to work the distance formula and can find that radius that's missing. We'll do one more example and then we can just let her go, because I'm not going to go into reference angles today. Because I'm tired, and that's a long explanation. So what if we let, for another example, let -2, that is not a 2, -2, 3 be a point on the terminal side. Right, we want to find all 6 trig functions. So we know our x equals -2. We know our y equals 3. We just need to figure out what our r equals. So we're going to go r equals the square root of x squared plus y squared, which means the square root of -2 squared plus 3 squared, which is 4 plus 9, which equals the square root of 13. Leave it. If it doesn't break down, it's just the square root of 13. Right? They're not all going to be perfect for us. But when we have a problem like this, right? When I go to do my sine of theta and we've got, oh, well, that's y over r. which is, sorry, I wanted to do x over 3 over the square root of 13, you're going to have to rationalize that denominator, right? And so we're going to have 3 radical 13 over 13, right? Your cosine of theta equals x over r. And so you're going to have to do the same thing anytime your r is in the denominator, right? We're going to have, in this case, -2 over the square root of 13, and you're going to have to rationalize that one too by multiplying times radical 13 over radical 13, which gives us -2 rad 13 over 13. So keep that in mind when you're doing these. If you get a square root in the denominator that's not a perfect square, you're going to have to rationalize that. Where we get lucky, though, is in tangent. Tangent of theta is just y over x. So we're just looking at 3 over -2. Nothing to rationalize there, right? Cosecant of theta equals r over y, right? We can think of it in terms of that, which means that it would just be radical 13 over 3. Don't need to rationalize it now, right? We won't have to rationalize secant either, because secant is going to be r over x, right? So it's going to be radical 13 over -2. And then when we get to cotangent of theta, it's just the inverse of tangent, so it's just -2 over 3. So keep that in mind when you have those r's in the denominator. If it's not a perfect square, you got to rationalize that denominator, right? Can't have your square root in the denominator. Any questions on that? No, everyone's doing pretty good. It's a fairly straightforward lesson, and I felt like I could have gone into reference angles, but I didn't want to make a video that was 8.5 hours long. Not that it would be that